Welcome to the Canadian Institute of Forestry's National Electronic Lecture Program. My name is Sharon Young, and I will be hosting today's session. Today is Tuesday, February 11th, 2025, and this is the second session in the e-lecture series entitled Advances in Operational Forestry, Tree Planting, and Carbon Mitigation Research. The series is a collaborative effort coordinated between the Canadian Forest Service and the Canadian Council of Forest Ministers. The CIF-IFC is very pleased to collaborate and host these webinars. For today's session, we are pleased to have Bryan Bogdanski, Keldi Forbes, and Nirmal Subedi, and Kaitlyn Fallow, who will give an exciting presentation titled Climate Change Mitigation Potential of Natural Disturbance Management: Economic, Institutional, and Behavioral Considerations. To kick things off, Dr. Bryan Bogdanski is the manager of the Forest Research Economic Group at the Pacific Forestry Centre in Victoria, BC. Bryan has been an economist with the Canadian Forest Service since 2000. Over the years, Bryan has worked on several forest-related issues with a focus on economic issues surrounding natural disturbances such as pest outbreaks and wildland fire. Keldi Forbes is the senior wildland fire research economist based at the Pacific Forestry Centre in Victoria. Her current research is focused on the economics of wildfire risk and prevention and mitigation actions. Other research areas of interest are institutional or jurisdictional opportunities and barriers to prevention and mitigation investment, and the economic impacts of wildfire smoke. Dr. Nirmal Subedi is a wildfire research economist at the Canadian Forest Service at Pacific Forestry Centre for the last 9 years. Prior to this position, he worked as a scientist and a policy analyst at the Ontario Ministry of Natural Resources and as a silviculture specialist at the Saskatchewan Ministry of Environment Forest Service branch. Dr. Kaitlyn Fallow is a behavioral science fellow with the Privy Council Office's Impact and Innovation Unit and Natural Resources Canada's Canadian Forest Service. She is based at the Pacific Forestry Centre in Victoria, BC. Her doctoral and postdoctoral studies were in cognition and brain sciences at the University of Victoria, where she researched human memory and how memory-related decision-making is influenced by characteristics of the remembered or forgotten materials. Her current research through the Program of Applied Research on Climate Action in Canada focuses on Canadians' attitudes, behaviors, and awareness around wildfire risk and resilience and the potential to increase engagement in wildfire risk reduction through behavioral science. With that, I will now pass it over to Dr. Bryan Bogdanski. Over to you, Bryan.
Thanks, Sharon. Hi, as Sharon said, my name is Bryan Bogdanski, and today myself and my colleagues Nirmal, Keldi, and Kaitlyn will discuss some of our combined research findings as they relate to natural disturbances in changing climate. This is a bit of a menagerie of research, but we hope to impress upon you the importance of solid forest information for social science research and policy development and decisions. So today's talk will cover several things. In this talk, we will discuss the importance of complete and accurate forestry and related information to conduct economic and policy analysis to support forest and land management decisions as they relate to climate change, be they for mitigation or adaptation. Firstly, we will briefly discuss the types of analysis that is typically conducted by economists and forest management analysts. Then we will demonstrate how different information can impact calculations. I will present a couple examples from pest disturbances and one for wildfire mitigation. My colleague Nirmal Subedi will discuss a couple more examples from wildfire. However, there are limits to the usefulness of economic analysis. Usually a full understanding of the problem, options, and trade-offs require complementary analysis and weighing many non-quantifiable considerations. My colleague Keldi Forbes will talk about how institutional issues may impact or limit wildfire mitigation management and possible solutions. Then my colleague Kaitlyn will delve into behavioral considerations that may limit the types of extent of actions. She will draw upon wildfire and carbon examples. We will then finish with a summary of some of the key points. So depending on the problem and available scientific and economic information, different types of economic analysis can be conducted. The simplest type of analysis is cost analysis. This analysis requires information on costs of alternative management options. This does not require an attempt to measure benefits, but it assumes each action has similar benefits. The least cost approach is chosen. A more involved analysis will look at alternative actions that will achieve the same measurable outcome. The outcome will be something like a measured reduction in chance of fire or a reduction in the chance of a pest outbreak. The option that achieves the objective at least cost is the most cost-effective approach. The last form of analysis looks at various management options and quantifies and monetizes the benefits with each option. The option that achieves the greatest difference in benefits and costs is the preferred option. As we move from simple to more complete analysis, the information requirements increase considerably. Due to incomplete data and information, some mix of approaches may be conducted. That is, the actual analysis conducted is shaped by the available information. So let's look at the mountain pine beetle as an example. So in this case, the timber inventory information can impact economic results greatly. By as early as 2005, there were great concern the mountain pine beetle outbreak that took hold in British Columbia would expand across Alberta and then move eastward through the boreal into Quebec, Ontario and Quebec. Programs were established to try and slow the eastward spread. Internal unpublished analysis by CFS was conducted. Several challenges were faced. The first was a good understanding of the rate of spread of the mountain pine beetle population with and without intervention. The second was the level of expected damages. The latter was largely dependent on the timber inventory input into mortality modeling by ecologists. To better understand the relative importance of timber inventory in results, analysis was conducted using provincial and national inventory. The two provinces looked at were Alberta and Ontario, and the national inventory was the KNN NFI, or National Forest Inventory data. Significant differences between total softwood inventory, total pine inventory, and age class distribution, which are all important for mortality modeling, were found to be very different between the provincial and federal inventories. This led to the calculated timber damages, which is a proxy of the potential benefits from slowing the spread of the mountain pine beetle, to be very different between inventories. The calculated damages represents the maximum level of management effort that can be justified to slow the spread and reduce the timing of the damages based on foregone timber values. The difference in damages between the two inventories range between 2 to 3 times, depending on assumed rates, annual rates of spread, discount rates, and future climate projections. The large difference in values can lead to disagreement amongst decision makers across different jurisdictions as to what level of effort and funding is appropriate, all else considered equal. However, the analysis did show annual damages are non-trivial and some level of annual management is justified. Also, the results found, regardless of inventory used, a warmer climate increases expected damages, though not substantially based on current climate projection scenarios. A similar issue arises with analysis of the impact of introduced species. A recent study carried out by CFS for the Canadian Food Inspection Agency investigated the potential damages from the southern pine beetle that is established in the northeast of the United States and could move northward with shifting climates. Again, there were significant differences between federal and provincial inventory, with federal estimates of pine below provincial estimates. For this analysis, the higher provincial information was used. The results found most vulnerable pine is not expected to be exposed to southern pine beetle populations in the short to medium term, that is over the next 10 years, and thus projected damages were minor. In this case, the inventory information chosen would not have changed the results and conclusions. Now let's turn to wildfire. There are many ways to mitigate the risk of impacts from wildfire, as nicely outlined by FireSmart Canada materials. Some of these occur within the built environment and some within the surrounding areas, sometimes referred to as the wildland urban interface. One of the key management questions for land managers is if and how much forest fuels management should be done around communities located in landscapes with hazardous fuels. A forthcoming CFS publication explores this question and introduces a simple method of analysis. However, even with this simplified analysis, the information demands are great. A key piece of information in the analysis is an estimate of the current annual probability of an area experiencing a moderate to severe wildfire and how that probability would change if forest fuels are changed through some form of management, such as total removal of vegetation, thinning, species switching, fire breaks, or prescribed fire. Without a good understanding of the existing vegetation, existing mitigation measures within and outside the community, and the effectiveness of additional mitigation within the WUI, any economic analysis will be highly uncertain. Improved vegetation inventory, improved understanding of the effectiveness of adaptive forestry practices to reduce the wildfire risk, and improved methods of assessing base case and projected hazard will go a long way to reduce the uncertainty of the economic analysis. So trade-offs between competing mitigation actions can be properly assessed. Improved forest fuel and forest mitigation information not only supports better economic analysis, but will go a long way to supporting better communication and cooperation amongst all members of the public and institutions. My colleagues Keldi, Forbes, and Kaitlyn Fallow will discuss this in more detail. Now I will turn things over to my colleague Nirmal. Nirmal?
Thank you, Bryan. Now I'm going to talk about wildfire disturbances. Can you hear me? Good. Although wildfire is a natural disturbances of many ecosystems of Canada, since 2017, the extent and intensity of the wildfire disturbances increased significantly in many provinces across Canada. Over 7.5 million hectare area burned out of almost 73 million hectare of wildland in BC. Prior to 2017, the total area burned over 8 years was less than 1.5 million hectare. It has also emitted over 849 megaton of CO2 equivalent. The figure on the right includes the location and size of the wildfires from 2017 to 2023, the cost of wildfire preparedness, response, and limited post-fire land-based recovery and rehabilitation, such as danger tree removal, fire guards, and stream crossing rehabilitation has costed province almost $5 billion with an average annual cost of wildfire management well over $600 million. As a result, the average cost of wildfire management alone is over $680 per hectare area burned in BC. There are knowledge gaps on understanding the full extent of the direct and indirect cost of wildfire, and understanding of these economic impacts is key to making effective and efficient decisions related to the wildfire risk reduction. Next slide, please. We reviewed the literature and found that existing cost accounting frameworks were not suitable to the Canadian context, mainly the way data is collected across various cost categories. As a result, we developed our own cost accounting framework, which can be summarized in 4 bullets. It uses a regional approach and the changes in the employment and production to the impacted region, including any disutility or additional social cost to the people that are impacted is only included. We used a bottom-up approach to identify economic, social, and ecological impacts of significant wildfire events within the region. Changes in the flow of goods and services were preferred to the changes in stocks. We use the best available science information as a guiding principle for compiling the estimates of wildfire cost plus losses and damages. Next slide, please. Wildfire produces a range of effects, beneficial, neutral, and harmful on vegetation and land they encounter in a unique way. Our accounting framework includes 3 cost categories, namely direct, indirect, and risk mitigation. The direct costs are those from the direct impacts of wildfire. The indirect costs are follow-on costs from immediate destruction of wildland communities and other assets due to wildfires. These costs occur inside and outside of the area burned by the wildfire. Some of these costs are directly observable through market prices. They are realized as decrease in cash available for use on other things or increase in the amount of spending necessary to avoid harm. Others are non-market values, meaning that they do not have an immediate cash effect, but represent a reduction in quality of life or economic well-being in ways that are quantifiable in dollar terms. There are 6 cost components in direct and 3 cost components in indirect and 5 cost components in risk mitigation cost categories. This wildfire disaster economic impact assessment framework is consistent with the Sendai framework for disaster risk reduction. Next slide, please. There is a growing body of literature on ecosystem functions and valuation. There remains gaps in linking biophysical ecosystem functions to human welfare or benefit relevant indicators. This conceptual diagram shows causal chains connecting a post-fire changes in forest structure, forest floor structure, and riparian aquatic zones and their potential effects on human well-being. Sorry for a busy slide. Detailed information on this can be found in upcoming CFS report. The take-home point is that in this study, we focused on the post-fire changes on BRIs, blue boxes in the right, such as missing number of swimming days, fishing days in a lake, or number of fish caught per day in a lake or river by the residents and visitors. Thus, tracking changes in the flow of goods and services that are utilized by local and visitors are essential to estimate these losses or benefits in dollar values. Next slide, please. Here are the results of the 5 case studies. The total estimated known direct and indirect cost across the case studies range from 90 million during the 2014 Kekisha fire, Northwest Territory, to 7.2 billion during the 2016 Horse River fire, Alberta. There is a huge difference in the amount of estimated total cost and its distribution across cost categories. Basically, the known costs were pretty much dependent on the socioeconomic status, extent of damage or destruction of the built-in capital, and levels of effort needed for post-fire recovery and rebuilding, and the extent of business interruption. During the 2016 Horse River wildfire, over 2,400 residences or over 1,950 structures were lost due to wildfires. It is one of the largest insured property losses in Canadian history, causing over 4 billion insured damages. Business interruption was estimated to be around 1.9 billion due to the disruption to the oil and gas industry operation, and the disaster assistance was estimated around 760 million. The cost categories directly related to timber harvesting land base, old growth forest, and post-fire restoration of damaged land and water bodies, and areas with potential risks of secondary hazard, such as landslide, debris flow, and flooding were identified. Our research indicated that to maintain sustainable supply of timber, there may be additional renewal cost for the regenerating areas with young trees following past disturbances, such as harvesting and wildfires. As there may not be sufficient seed trees and undergrowth to support the renewal of timber harvesting land base, the burn area may require artificial regeneration. Next slide, please. This is the same information presented in terms of percentage of the known total direct and indirect cost across 5 case studies. It does not include the human health-related direct and indirect cost and indirect intangible cost associated with damages to ecosystem services. Please note, if the unknown direct and indirect costs not included in the case studies are known, then the percentage of the cost represented by each cost category can change. Among the known direct and indirect costs, the protection from wildfire, property and content losses, and business interruption, and the disaster recovery expenses are the major cost categories of the studied wildfire seasons. The foregone stumpage value, cost of artificial renewal of commercial forest area, and foregone old growth forest are directly impacting forestry sector. Similarly, the restoration and rehabilitation of the damaged wildlands are also additional costs to the sector. I have prepared separate poster of each wildfire season. If you are interested, please email me. I will send you the poster. In addition, I am open to giving a presentation at provincial or territorial level if there is a demand. A BCX report summarizing this study is forthcoming. Next slide, please. The wildfire risk management strategy is based on 3 pillars. First is to have a safe and effective wildfire response when needed to protect communities and important values and assets. Second, taking proactive measures to make communities fire adapted. Implementation of fire smart principles around homes and communities and use of fire-resistant materials in fire-prone areas can make communities and infrastructure fire adapted. Third, by introducing more fire on the landscape by using cultural and prescribed burning, and even a modified response when appropriate can make landscape fire resilient. Similarly, research suggests that the assisted migration and use of seedlings of drought and fire-resistant trees and increasing hardwood mix during renewal and stand-tending operations will make landscape resilient in the face of changing climate. We need to find the new balance in using these approaches to reduce the economic, social, and ecological impacts of significant wildfires and better prepare to live with fire. From 2003 to 2023, the province of BC spent about 300 million in wildfire risk reduction around communities in British Columbia. As the marginal cost function for each category is upward sloping, which suggests that the optimal strategy need to include both reactive and proactive measures. As the intensity and frequency of the wildfires are expected to grow, using only reactive approaches may be very expensive. To understand the benefit cost of investment on wildfire risk reduction projects, we need more information. The wildfire adaptation measures are place-based and needs to be tailored to unique situation. We need a lot of information like effectiveness of fire guard around WE communities or timber harvesting land base to contain wildfires across various fire weather conditions, burn probability, identification of areas that require fuel treatment by a registered professional forester, and estimated avoided wildfire benefits to conduct economic analysis. My colleague Keldi and Kaitlyn will speak about the opportunities and challenges related to wildfire risk reduction. Keldi will focus on boundary spanning problems, and Kaitlyn will talk about human dimension research on wildfire risk reduction. Thank you.
Thanks, Dr. Subedi. So I wanted to briefly speak about another aspect of costs posed by wildfires. Those are smoke impacts. Smoke is the furthest flung wildfire hazard. It readily crosses jurisdictions, needs different types of organizations to address. It's often harder to tie to a specific wildfire event. The mental health impacts from wildfire smoke exposure gained attention following increasingly smoky summers around the world. Here in BC, wildfire smoke is considered a hazardous substance, requiring any signs or symptoms of smoke exposure to be handled as a workplace injury. Canada's peak outdoor labor season often coincides with the highest smoke prevalence. Recent research has shown that labor hours decrease by 2.5% following a smoke event. That effect can persist for up to 2 years. With wildfire occurrence expected to grow in the coming years, this may have considerable implications for many industries. Next slide, please. So next I'll speak briefly about insurance. So insurance is the most widely adopted mitigation measure, and the role is getting significant attention in recent years, both for economic risk mitigation and as a potential lever for physical mitigation. It involves organizations outside the forestry sphere, and often transnational financial intermediaries. Better satellite mapping of features such as fuel density and slope, along with weather, mean data availability, quality, and granularity has grown dramatically. Insurers are taking increasing advantage of this. Decision makers and policyholders have access to better information sources as open data, including risk mapping over more distinct geographical sites, improves. However, the sophistication of proprietary insurance models means insurers working with land use planners, forestry experts, communities, governments, and other stakeholders to improve decision-making is mutually beneficial. Next slide, please. If we see what is happening in very high-risk jurisdictions such as California, the risk of reduced private insurance offerings is a concern. Growing numbers and costs of natural disasters, including wildfires, led to a growth in reinsurance, particularly for catastrophic risk pools. Historically, reinsurance has been done through private companies around the world, but around the world, more governments are becoming involved. This marks a shift, as typically governments' role in risk management has been to develop supportive public policies where they have the ability and authority to do so. Public-private partnerships can improve affordability for policyholders, provide a source of funds for government to invest in risk mitigation. But this approach exposes government to financial risk on two fronts. First, as governments face costs during and recovering from natural disasters, they then secondly face the need to pay out on the reinsurance policy. These risks are likely to raise further questions about mitigation options across many landscapes. The next slide, please. So a challenge to protecting people, structures, and infrastructure in the WUI is that the best protection is multifaceted and is typically under various authorities. For example, fuels and fuel management surrounding communities are best informed by practitioners and foresters, while the authority for undertaking the work differs community to community. Within the communities themselves, structures are ideally built with resilient materials. These are informed by building codes and fire codes. This can be national, provincial, or territorial, along with municipal bylaws if applicable. Outside the structures, there's property design and landscaping, such as sheds, wood sheds, and flammable fuels. These are often dependent on property owners, but sometimes can be addressed through bylaws. There's also the overall community design, such as proximity of structures, properties to each other, vegetation within the community outside of private lands, road design, and evacuation routes. These tend to be informed by municipalities, land use planners, emergency planners, and first responders. This shows how effective risk reduction requires multiple pieces in place in and around the WUI. Next slide, please. Given this, various players are looking at what they can do within their mandate or authority. For example, work is underway exploring incorporating fire smart building principles into Canada's National Building Code. However, any code changes are typically quite a long process, often more than 5 years. Provinces and territories have varying degrees of alignment with the National Code. Some adopt it entirely, and others amend it for their unique needs. Most municipalities also have the ability to add requirements for building, treating the relevant provincial or territorial codes as the minimum requirements. Two examples of municipalities that have been able to undertake significant work to reduce the risk of fire surrounding their communities as well as within them are Logan Lake and Whitehorse. Next slide, please. Looking at Logan Lake is recognized as a success story following the 2021 Tremont fire, which burned into the municipal boundaries. There was no structure loss, although damage affected recreational trail networks. Prior to the fire, the town spent close to 2 decades undertaking fire risk reduction measures, ultimately becoming the first fire smart community in BC. Logan Lake had both challenges and opportunities. A large section of the area which is high wildfire risk, along with a high number of values at risk. Efforts dating back to 2003, initiated by the Logan Lake Fire Safe Committee, led the district to go through the process to acquire a community forest license. Next slide, please. The community forest in Logan Lake is dispersed throughout the district. By managing it themselves, they're able to strategically control harvesting, along with stand management, non-timber ecosystem goods and services, development planning, and infrastructure. Taking this approach has enabled the town and harvesters to reduce fire risk across the area. They receive strong support from the community, providing forestry employment, the social license to undertake the work, and widespread adoption of fire smart principles by property owners. Approximately 1/3 of the homes in the community have rooftop sprinklers. These were installed by the Logan Lake Fire Department at cost. As part of the installation, the fire department also gave advice on how to further fire smart the properties. Next slide, please. The second example I wanted to speak about is the Whitehorse South Firebreak Risk Reduction Project. This fieldwork project is an excellent example of collaboration across the city, First Nations, the territory, forestry experts, and citizens. Planned to be about 20 kilometers long and varying in width from 200 meters to 2 kilometers. It is designed to reduce the risk posed by densely packed spruce trees in the boreal forest, which border the city and face prevailing winds through the Carcross Valley or the fieldwork area into Whitehorse. They're not universally embraced. The project has grown in popularity through careful collaboration and consultation. There's communication about the risk reduction benefits to community members. Next slide, please. Planning and consultation led to identifying research needs to successfully treat the area, identify co-benefits for residents. Some areas are being fully cleared with intention to replant with aspen and berry bushes. Limited marketable timber is found in the area, either due to the size of the trees, lack of processing facilities. As a result, much of the harvest is set aside for public salvage firewood, which is the primary residential heating fuel in Whitehorse. Other areas of the firebreak are being thinned, with some isolated stands left to serve as windbreaks and watershed protection. As part of the work, experimentation is ongoing with respect to post-harvest mulching protocols and species choice. The species and spaces are planned to be slow burning and maintainable through prescribed burns in the future as needed, along with providing access and defensible space. New cross-country ski trails were incorporated into the fieldwork and surrounding area as part of the work. Collectively, these measures and efforts provided the social license needed for this massive project. With that, I'll hand it over to my colleague, Dr. Fallow.
Thanks, Keldi. So as Keldi emphasized, a multifaceted whole-of-society approach to reducing risk at the wildland-urban interface will have the best chance of success. And this is something that will require multilateral communication between different groups. So from the forestry industry to different levels of government and to individual residents and so on. So we really want to do this kind of communication to understand and address different kinds of trade-offs, barriers, and priorities that might be in play in these different WUI communities and for different people within those communities. So much like the hazard itself, these things can vary quite widely. So my next few slides will focus on sort of the national picture and trying to understand what's going on with Canadians as a whole when it comes to understanding and acting on wildfire risk. But it'll be important to keep in mind that what works in one community will not necessarily work everywhere. So this communication really has to be ongoing and evolve based on community needs. Next slide, please. So part of successfully communicating with Canadians about wildfire risk and how to reduce it will be just understanding what they know and what they don't know. So to speak to some national level data we have on this, we surveyed around 3,200 Canadians in February and March of last year and found only 33% had looked for information about local wildfire risk in the last 5 years. So a lot of people may be missing recent information, leaving them ill-equipped to make decisions about whether and how to prepare. Only 25% knew that wildfire damage to homes and other buildings tends to be caused by embers. This principle, of course, underlies a lot of recommendations about how to reduce risk. And if your kind of concept of wildfire damage is limited to flames coming through a community and just burning everything to the ground, you might not think that much can really be done to protect homes and communities. So that's one reason this is a really important knowledge gap. The other is that it can leave people vulnerable to mis and disinformation that we know is out there. For example, bad actors suggesting that increasing wildfire activity has nothing to do with climate change. It's just all people setting fires. They'll sometimes show pictures of burn patterns to support that assertion, and those pictures can kind of be compelling and seem suspicious if you don't understand the ember mechanism. So that's an important knowledge gap to address. We also found that 45% of respondents didn't know if their communities had taken any kind of action to reduce wildfire risk, like building a fire break or even developing a plan to deal with risk. Only 28% were familiar with FireSmart, and much of this was low familiarity. And then a lot of homeowners in this sample didn't know whether their homes and properties had various kinds of fire smart features. And correspondingly, a lot of people mentioned that lack of information as part of the reason they hadn't implemented any of these measures. Next slide. So there are also a lot of gaps in our understanding of how Canadians think and make decisions about wildfire risk. So we asked participants, to the best of your knowledge, what is the overall risk of wildfire occurring in your local area? And although only 4% of people explicitly said that they didn't know, we don't know how accurately these other responses here really map onto what's going on in the respondents' local area as far as the hazard. So some of our colleagues are working with this data to try to correlate it with hazard maps, but the resolution of these data sets tends to be quite different, so it's a difficult undertaking and more data might be needed to really understand this. And it will be important to understand, of course, because there is potential for error in either direction. So people may underestimate the risk and not take action to prepare or mitigate when they should. And this is, of course, the really worrisome one. But people may also overestimate risk and worry unnecessarily or waste money and time on mitigation that they could better spend on, focusing on hazards that are really more significant where they are. So right now at the national level, we just don't have a good sense of how much either of these types of error are happening. And we don't know things like whether there might be regional trends that could be addressed with tailored communication, for example. Next slide. So putting out information is kind of the bare minimum in terms of empowering Canadians to make informed decisions about things like wildfire risk reduction, both in their own lives and in just terms of larger scale policies and programs as well. So it also matters how and when the information is presented. So just to cover a few examples from our work, we tested a few different messages here to see if they increased interest in wildfire risk reduction, like various fire smart measures. And respondents who saw a message that emphasized that wildfire is a shared risk and reducing risk on your own property can help protect others like your neighbors or firefighters if they have to fight a wildfire in your community. Those people who saw that message expressed stronger intentions to learn and engage more about local wildfire risk compared to those who just saw a control message that just kind of had basic information about wildfires in Canada and how to reduce risk. And then looking at this graph on the right as an example here, we also found that respondents whose homes had fire smart features or who were planning to install them were often motivated by things other than reducing wildfire risk, like wanting to increase property value, make their homes look better, improve energy efficiency, and so on. So emphasizing these kinds of co-benefits above and beyond reducing wildfire risk might be a promising way to increase interest in some of these things. And then just more generally, in trying to get Canadians more engaged in climate mitigation and adaptation efforts, really thinking about the values and priorities of different audiences and the different barriers to taking action that they might face can help ensure communications are more relevant to them. And finally, making sure that information is available to people at the right moment when they're making a related decision can also help make it more impactful. So in this case, a lot of respondents indicated implementing fire smart features when that part of their home needed to be replaced anyway, pointing to a key moment for intervention. Now we know that people are often making decisions about their home under conditions of some urgency and stress. So it'll be important to advertise fire smart options generally, but also make sure that they're on people's radar at the right time. So an example of how we might approach this in this case would be through experts like roofing companies and other contractors that homeowners might consult for this kind of decision. Next slide. So these kinds of partnerships with experts can be important not just for reasons of timing and just kind of logistical considerations, but also for reasons of trust. So we asked participants here how much they trusted various groups to provide good advice about how to protect their homes and properties from wildfire. And local fire departments were the most trusted by far at 83% trust. Provincial and federal governments were much less trusted on this issue, down at 56 and 51% respectively. So it's important to have this question of who are the trusted messengers on this issue in mind when thinking about how best to communicate with the public. So Often people or groups who are more local and really understand the community context may be better situated to provide certain kinds of information. So partnering with these groups or supporting their existing efforts can sometimes be more valuable than, for example, a less trusted institution starting a communications campaign from scratch on their own. Next slide. So just zooming out a bit to think about communications related to climate change adaptation and mitigation efforts in the general kind of forestry context, we know that most Canadians believe in climate change and they're at least somewhat supportive of doing something about it, including making big changes in their own lives. But our understanding of Canadians' knowledge and perspectives on climate action in the context of forests specifically is more limited. And we know that this is a space where there is substantial mis and disinformation. So you'll sometimes see, for example, the argument that, oh, we don't really have to do anything about climate change because forests absorb so much carbon. We can just plant new trees and that will take care of it. So understanding what Canadians know and what they misunderstand about forest carbon and this relationship between forests and climate change will be really important for designing communications about these issues to really help people make more informed decisions and be less vulnerable to this kind of mis and disinformation. So the next few slides will just show results from this same survey of around 2,000 Canadians that we conducted early last year. Next slide. So one theme that stood out in these findings was that most respondents really don't think of Canadian forests as a source of carbon emissions. The carbon sink and storage function of forests is really much more salient in the public understanding here. So 59% of our sample thought that Canadian forests have consistently been a carbon sink over the last 2 decades, and a similar number expected that to continue. And only around a third indicated that they saw forests as a major source of carbon dioxide. So we didn't directly ask people about this, but the picture that's kind of emerging here is that there's a major underappreciation of the scale of emissions from natural disturbances in forests. And we have some indirect support for that from a couple of open-ended questions we included in this survey, where we asked people, firstly, what comes to mind when you think about the relationship between forests and climate change? And second, how do you think forests affect the level of carbon dioxide in the atmosphere? So wildfire was one of the most common themes that came up for that first question about just kind of the general relationship between forests and climate change. So it's certainly top of mind for a lot of people, but it was almost never mentioned in responses to the question about carbon specifically. And insects and other pest disturbances really didn't come up as themes here at all. So these disturbances really don't seem to be an aspect of concern around climate change that is on a whole lot of people's radar just yet. And this skewed understanding of the role that forests play in the carbon cycle and how that's being affected by climate change leaves people poorly equipped to understand the implications and effectiveness of different kinds of climate policies and practices. Next slide. One particularly concerning example of this was that although most respondents here agreed that climate change poses a risk to forests in Canada and that forests will play a big role in mitigation, they seem to think that this role could potentially negate the need to reduce emissions from fossil fuel sources. So 63% endorsed this statement that further climate change can be limited by planting new trees instead of reducing how much of these fossil fuels that we use. So this is just one data point, and people sometimes aren't, being super thoughtful when they take surveys. So we can't be sure all respondents really focused in on that instead of, which is really key here. But it's a concerning result, and we know that this is a kind of misinformation that is out there. So in communicating with the public about how forests can help mitigate climate change, which of course they can, the potential to unintentionally reinforce this misconception that forests can be the only solution and kind of get us out of having to reduce emissions should be kept in mind. Next slide. So just to wrap up my section on a more optimistic note here, Canadians do seem to be generally supportive of forest management approaches to mitigating climate change. I won't go through these one by one here, but this graph is just sorted by level of support. So you can see the most supported strategy at the top there was planting trees in wildfire and insect affected areas, and down to the least supported, which was applying fertilizer. But even there, you still get majority support. And this order roughly tracked with how effectively people thought these strategies would reduce CO2, which is another graph that I won't show here. But this high support, of course, won't always translate to public buy-in for specific projects. Communities may have different priorities and concerns about plans to implement these things in their area. So the details will matter and communication will matter. But in theory, the support is there for applying forest management practices to help mitigate climate change. So with that, I'll hand it back to Bryan to wrap up.
Thanks, Kaitlyn. So to quickly sum up, economic analysis of forestry management decisions to adapt or mitigate natural hazards now and into the future, first and foremost requires good forestry information and understanding of the interactions involved in the management of the complex biological systems. This will lead to less uncertainty and a clearer idea of the trade-offs between competing management actions. However, even if the economic analysis is improved, considerations of the constraints to implementation and a good understanding of the awareness, perceptions, and attitudes of different groups of the population is equally important. That is, improved forest information begets improved economic information that begets improved communications, which in turn enables improved cooperation and coordination between members of the public and agencies responsible with acting in the best interests of the public on public lands and best adapt to climate change. So thank you very much for listening, and we welcome any comments or questions. Sharon, should I stop the slideshow?
Yeah, that sounds good. Thank you, Bryan, Kaitlyn, Nirmal, and Keldi. That was a great presentation. Now let's move on to the questions. While we wait for participants to finish typing their questions, please take a moment to fill out the post-webinar survey, which I'm gonna launch it now. Just a reminder that there are 2 questions, so you may need to scroll down to see the next one. All right, so the first question in the Q&A pod is, could the insurance industry provide more incentives for fire smarting of structures, properties, and communities?
I can take that one if like. So that's a great question, and that is something that's being explored both at the national level by Fire Smart Canada and by a number of the provincial fire smart programs as well. Certainly, rebates would be, probably the ideal thing we'd like to see. The challenge is that a lot of the modifications to homes tend to be quite costly, so take quite a few years to recover that through what can likely be offered through rebates. Which sort of points to Kaitlyn's point that getting these resilient building materials into people's homes at key intervention points, like when a roof needs to be replaced, is likely the most beneficial approach. That said, a number of insurance companies are also now providing some of the fire smart information to policyholders when it's time to renew. Not necessarily as a rebate, but just to give that information out to people so that they're thinking about it.
Thank you, Keldi. So the next question is, do current forest inventories like AVI in Alberta provide the vegetation detailed information required for appropriate mitigation decisions?
That would probably be Nirmal or I. Nirmal, do you want to take that one?
Yeah, we haven't looked on the AVI inventory information data, so we are unable to answer these questions. And basically, like for the wildfire disaster cost benefit analysis, we kind of like the main driver of the benefits is the burn probability, historical burn probability or likelihood of the wildfire event. So I don't know what kind of new information by the AVI can improve that estimate. I don't know. We haven't looked on that. That's a good question. Thank you.
Thank you, Nirmal. All right, moving on to the next question. Bryan, thank you and your team for this highly informative presentation. The talk is well structured and the messages are clear and impactful. I have a question for Nirmal. Which of the three pillars is most challenging to implement? For example, safe and effective wildfire response, fire adapted communities, and landscape resilient.
This is good question, but like as an economist, we want to see as a cost benefit analysis. So there may be lots of learning down the road. What I have read from the publication in the US is like the effectiveness of the fire guard and firefighting effect are also sometimes it is working, sometimes it is not working because it is a very costly endeavor. So when these information are compiled, we can have a better understanding of the effectiveness of the safe and effective wildfire response. And in case of landscape level changes also, lots of thoughts are ongoing on the ecological level, but we haven't seen any data to crunch. So still like we need more time to answer these questions. Bryan, do you want to add something?
No, I think you covered it well there, Nirmal.
Thank you, Nirmal. For the next question is, are there considerations for other natural disturbances such as hurricanes?
Well, I can address that one. I think so probably as a preconditioner for other disturbances such as pests or wildfire, yes. Certainly they can be incorporated, and it certainly would be advised to incorporate any multi-dimensional aspects for designing appropriate forest management practices on the land. Certainly in Maritimes with the issue of hurricanes and certainly storm patterns and how it affects vegetation growth and the types of assemblages that you get there, and it certainly poses a challenge for wildfire mitigation and vegetation management for wildfire. Not to mention just general regeneration. And then certainly, yeah, wind throw would be the other one, which should be incorporated into any good planning as well. Again, the knock-on effects on pests and also possible fire loading fuels on the land base. So, and I think there's some good examples of current best practices, and certainly in my area that I know of, which is in British Columbia, certainly the combination of wind throw is incorporated with wildfire and also pests. So it needs to be an integrative approach. So I agree with that much.
Thank you, Bryan. The last question is for Kaitlyn. So the survey conducted in 2024, what is the percentage of respondents being homeowners? What about age structure of the respondents?
Yeah, thanks for the question. So for the wildfire survey, that sample was mostly homeowners. It was 64%. And the age structure was roughly nationally representative based on the 2021 census, looking at kind of broader age groups. But I think the youngest age group, like 18 to 34-ish, was a little bit underrepresented in that sample.
Thank you, Kaitlyn. Well, if there are no more questions, I would like to bring this session to a close. Thank you all for participating in our CIF electronic lectures. And once again, thank you very much to Bryan, Nirmal, Keldi, and Kaitlyn for the great presentation. Bye, everyone.
Thank you.
Thank you.